Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on how to approach different questions when it comes to IAL, that is Advanced Physics, AS, Mechanics and Materials. So this is due to the request that had been made by some of the subscribers who have joined A levels. So I need to say that the first paper that you're going to do, the first unit you're going to do is Unit 1, which is Mechanics and Materials. So in this video, we're going to have a discussion on some of the questions that you'll be asked and how you're supposed to approach them. Answer C. Now, a ball bearing falls vertically from rest through a distance of 50 centimeters. Now you can see here we're given distance in centimeters. You have to convert it into meters. And the time of fall here is 0.32 seconds, which expression gives the acceleration of the ball bearing in meter per second square. The displacement or the distance that was given here was 50 centimeters. So meaning we can be able to convert that to meters, and that gives us a value equivalent to 0.5 meters. Now, remember, we are told the ball bearing falls vertically from rest. So meaning the initial velocity was 0 at that given point. So we cannot have that ut. Ut will cancel out, and then we shall have a half times acceleration times time, but our time is actually 0.32, right? So we can be able to substitute 0.32 squared. Since we are trying to find the expression for acceleration, we are going to rearrange the formula. So what you realize that in year 12, you need to have a good understanding of these two equations so that you can be able to apply them any given point. So if we can be able to check where do we have, because 2 times 0.5 will give us 1. So where do we have such expression that is actually representing A? So A is the best answer for that part. Now let us move to the next question, get to see how you can be able to do question to do with projectiles. Yeah, so this is a projectile motion, so be prepared to answer questions like this also. Now, for projectile motion, you realize that motion in the horizontal direction is not affected by gravity, but motion in the vertical direction is affected by gravity. Which of the following expression could be used to determine the value of S in meters? S is how far it falls from the base of that table. So we can be able to see that S is actually the range. S is called the range. The distance from the point of projection to where it lands is actually called the range, and that is usually because motion in the horizontal direction is constant. Therefore, you can say is the initial velocity of projection times the time it takes to land on the point there. So we can be able to see that initial u is the initial horizontal velocity, and then we have t is the time, right? T is the time, and S is the displacement. All right, so we can be able to substitute what we have in order to work out this question. So let's go ahead now, try to substitute what we know, that is 1.2 times the time it takes, which is actually 0.9. So you can see our answer is going to be 1.08 meters. But in that case, now we were not asked to work it out. You were supposed to give the expression that can be used to determine the distance S. A racing car passes point P at a speed of 35 meters per second. The car accelerates uniformly, and after 5 seconds passes point Q at a speed of 50 meters per second as shown. So which means that 35 is initial speed and 50 is the final speed, but it takes 5 seconds to move from P to Q. need to identify what information are we given in the question and what we are finding. And what we are finding is the distance between P and Q. Now, at that point, you can be able to choose the most appropriate Stewart equation. These are the equations of motion that we know, and we can be able to include the last one of average speed. Average speed times time gives you the distance. So you can see now, with the information provided, we don't have acceleration, and we are not asked acceleration. We are asked to find displacement. So the best formula to use is S equals to U plus V over 2 times the time that we are given there. So if we try to substitute, you can see the best option there is actually C. C is the correct answer in that case. In question 5 is motion on an inclined plane. So these are some of the questions also you may be asked to work out. So we are told that an object accelerates from rest down a frictionless slope. The object moves a distance of 20 meters and the slope is at an angle of 23 degrees to the horizontal as shown here. Then we can see now the distance covered by the object down the slope is 20 meters. Now, which of the following gives the final speed of the object? Remember, this object started to move from that particular point down the slope from rest. So the initial velocity was 0 meter per second. Now, we need to understand that gravity is actually vertically down like that. So this is G. Then if we can be able to resolve this G along the inclined plane and at normal to the inclined plane like that, this angle is actually 90 degrees. Then this angle we have here is equal to 23 degrees. This theta is equals to 23 degrees. Now, this component of G here is going to be G cos theta, and the component that is down the slope is G sin theta. So anytime you are having inclined plane like this, the component of G that is perpendicular to the plane is G cos theta, and the component of G that is parallel to the inclined plane is G sin theta. So we can be able to find what is the value of the acceleration down the slope. So since we know it's 9.81, we can be able to say the acceleration due down the slope is G is actually 9.81 sine 23 degrees. 23 is the angle of inclination in that case. Now, since we have our acceleration to be G sine 23, which is actually the same as 9.81 sine 23, we can be able to use the Stewart equations of motion in order to work out the final velocity. And the best one we can use is V squared equals to U squared plus 2as. Our acceleration we have obtained there. So we can be able to substitute the values, and remember the object was moving from rest, so the initial velocity was 0. So if we substitute everything that we have in this case, and then let me move this a little bit so that I can be able to have enough space, we can be able to find the square root both sides so that we can be able to find what the value of V is. So the expression for this case is actually C. So you can check also in the description, there's a link that will direct you on how you can be able to resolve different components when you're given a question like that. In the next question here, we are told that the velocity time graph shows the motion of a particle with a constant acceleration P, Q, and R represents the magnitude of each of the areas. Now, which of the following expression gives the total displacement of the particle? Now, when you are given a velocity time graph, something that you need to remember from a velocity time graph, you can be able to work out the acceleration by using the gradient or the slope of that velocity time graph. If you are asked to work out the displacement from a velocity time graph, you need to work out the area under the graph. But now in this case, you see the line is joining from the negative part to the upper part. So the region Q is representing negative displacement. R is a positive displacement. So which will mean that for us to work out the total displacement, we are going to add the two areas, R and Q. But since R is negative, our final answer is going to be R minus Q, which represents the total displacement in this case. So we can be able to say the total displacement of the particle is R minus Q. R minus Q, which is actually D. And the reason as to why we are saying that displacement is represented by the area under the graph, and these are the two areas we're talking about. Q being a negative area, so we can be able to say is R minus Q. Moving to the next question, here we are told a student walks for 6 seconds. The displacement time graph for the student is as shown below. So we are having now a displacement time graph. Which row of the table shows the final displacement and the velocity of the student? Now you need to understand, when time is 0, it means that's the initial point. So meaning the student moved some distance to the negative side and then moved from that particular point some distance to the positive side. So we can see now if we moved 1 meter down from the starting point and again now moved from that point back to 2 meters up in front of the starting point, then we can now say displacement is a distance from the starting point. So what's the distance from the starting point? This person is going to be 2 meters from the starting point, right? But velocity can be obtained from the gradient of a displacement time graph. So we can say displacement here is actually going to be 2, and that is 2 meters from where this person started. But we can be able to work out the gradient in order to get the velocity of the person. So the gradient here is going to be rise over run, and we can see now the rise is actually, we can talk of a rise of 2, and the time taken is 4 seconds. So that is going to be 0.5 meter per second as the velocity. And you can see this now, the part that represents that. So from a displacement time graph, you can be able to get the displacement of the object, and also you can be able to get the velocity of the object by finding the gradient. Remember also from velocity time graph, you can be able to work out area under the graph, which represent the displacement of the object. From acceleration time graph, if you work out the area under the graph, it represents the change in velocity. Now we can be able to move to the next question here, which is saying that a student determined the acceleration of free fall g. She measured the time t for a ball bearing to fall from rest through a distance s. She repeated this for a range of values of s. Which row of the table shows the graph that will give a gradient equivalent to g? Now remember, in order to work out this, we can be able to use this formula, s equals to ut plus half gt squared. But since it's falling from rest, it means that initial velocity is 0. So this particular part here is going to run to 0, and we shall remain with s equals to half gt squared. So this is the formula that can be used to work acceleration in free fall. You can see now we are having s equals to half gt squared. You can be able to plot a graph of s against t squared, then what you work out the gradient of that graph obtained, which is a straight line graph, which will give you a gradient, and that gradient will be equal to a half g. But now, since in this question we can see s does not stand alone, so we can be able to say if we multiplied by 2 both sides, we can have 2s equals to gt squared. So the graph that can be plotted is 2s against t squared, which will give us a straight line, and the gradient of that you can see now is going to be the gravitational acceleration due to gravity. So that is 2s on the y-axis and t squared on the x-axis. So that is part B. Okay. Is moving towards a stop sign at a speed of 25 meters per second. The driver applies the brakes 20 meters before the sign and decelerates uniformly to rest just before the sign. So let us see what we are provided with. In this case, we are provided with initial velocity. We are provided with displacement, which is 20 meters. They are provided with final velocity because it's coming to rest, which is 0 meter per second. Then we are supposed to work out now the car's deceleration, and in that case we can be able to substitute what we have in this question. Substituting into the formula, we can be able to say now this is negative because this car is decelerating, so we can be able to say 0 there because final velocity is 0. So you can be able to say 2as by just taking it on the other side, it becomes a positive, is 25 squared divided by 2s divided by 2s. So we have this cancelling out, and we shall have our a equals to 25 squared over 2 times 20, which translates to 25 squared over 40. So which expression is giving us that? That expression is C. Now, always whenever you are working out this question, don't simplify to the fullest. Keep on checking the kind of formula or the kind of expression that is given in your answer, so that you can be able to see which is the most appropriate answer to write. Now, an object on the moon falls a vertical distance of 0.32 meters from rest. So meaning the initial velocity at that point is 0, and it takes a time of 0.63 seconds. Which of the following 6 expressions gives the acceleration due to gravity on the moon in meter per second square? So remember, for us to work out the acceleration, we are going to use the Sulbert equations. And in that case, we can be able to say the initial velocity is 0, and the height it falls is 0.32 meters, and the displacement 0.32, yeah, which is in meters. We are told to find acceleration, which is g, and then the time it falls, that height is 0.635. Now we're supposed to use this Sulbert equation in order to work it out, but remember initial is 0, so this part here is going to be 0.32 equals to 0, and then equals to a half gt squared. Now, try to rearrange the expression that we have. We are going to see our answer is going to translate to C, 2 times 0.32 over 0.63 square. In question number 11, an object moves from rest with uniform acceleration for the time t. But I told you from the previous section that acceleration time graphs, the area under acceleration time graph will tell you the change in velocity. So x represents the correct answer in that case. So we are having this object moving at a horizontal velocity of 7 meters per second. That's the ball. The ball is traveling horizontally at a speed of 7 meters per second, and the ball hits the vertical wall and rebounds along its initial path at the speed of 5 meters per second. The ball has an acceleration of 300 meters per second square while in contact with the wall. Which of the following expression gives the time of contact between the ball and the wall? So can be able to see here is our wall, and this is actually the ball, which is moving at 7 meters per second. It rebounds back with a velocity of 5 meters per second. Now, what you need to remember, when it rebounds, it's moving in the opposite direction. So we are going to really consider some direction there. So remember, acceleration equals to final velocity minus initial velocity over t. So meaning that acceleration 300 is equals to negative 5 minus. We are saying negative 5 because we can consider the direction to the right to be positive, but to the left to be negative. So if the object was moving at 7 meters towards the wall, we can consider that positive. But when it's moving away from the wall at 5 meters per second, we can consider that negative. So negative 5 is actually the final speed. Initial speed was 7 meters per second because it was approaching the wall. Then so it will be negative 5 minus 7 over the time t. We can be able to rearrange this and have t equals to negative 5 minus 7. But you can see negative 5 minus 7 is going to be a negative, and with time can never be negative. So we can be able to change the acceleration to be, because we can consider it to be deceleration, and then we say this is negative 300. And the reasons why I've done this, because time cannot be negative, but acceleration can be. So that becomes what? If you work it out, the expression that represents that is A for that case. For that case. Quantities in physics are classified as either vectors or scalar. Which of the following units could only be used for scalar quantity? Now, we see meter per second. Meter per second can represent the unit for speed or velocity. So that is can be scalar or can be vector. Meter per second square represent the unit for acceleration, so which is actually vector. Kg meter per second square, this is actually force. Remember, from force equals to ma, so that's why we are getting that unit from. And d is the unit kg meter per meter square cubic. This is the density unit. So density is a vector. Density is a scalar quantity. So in that case, D is the correct answer. Two objects P and Q are at the same position at time t seconds. The graph shows how the velocity v varies with time for each object. Now we have the representation of the graph there, and remember that the area under the graph of velocity time graph represent the distance or the displacement of the object. Now, which of the following statement describe the position of P and Q at time t, which is 4 seconds? Now, if you look at each of them, we can be able to have some information regarding the motion of this object. Now, A, you are told P and Q are both at the initial position. That is not true, because you can see for Q, there is some area under the graph. So meaning Q has covered some distance. But P is in the initial place, because if you work out the area of the upper part and the area of the lower part, both of them are equal, but one has the opposite sign. So they will cancel out and the displacement will be 0. So which will indicate that the object is at the initial position. Yeah. Yeah, so P and Q are at the same distance from the initial position. That's not true, because for P, it is at the initial position and the area is 0, but for Q, the area is not 0 in that case. So can be able to say A is not correct, and the reason as to why we have said it's not correct is because area under the graph of the two are not equal, or are not both of them equals to 0. So that statement is not true. This one is not correct because the areas are not equal. Because if we are saying P and Q are in the same distance from the initial position, then the area under the graphs must be equal. if we are saying both of them are the initial position, then it means that area under the graph of the two must be 0, which is not true for A and for B. P is further away from Q. Yeah, P, you can see P is at the initial point. Q is the one that is having some area under the graph. So meaning that that statement is not true because P is at the starting point or the initial point, but Q has some distance. Then therefore, we can conclude and say that Q is further from the initial position than P because P is at the initial position, but Q, you can see there is some area under the graph, so it means it's somewhere far from the starting position. So if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials of A-level physics, you'll be notified. See you in the next video.